All right, so welcome in tonight. Tonight we're going to talk about chapter 7, and there's really three main types of problems in chapter 7. The first, normal probabilities. So what's different about normal probabilities, this is a continuous distribution, so the value of X can take on all kinds of decimal values. These are things that are measured instead of counted. But what really lets us know is the wording of the problem. So some things that you're going to see or you're going to be looking for is the idea of something being normally distributed. And you're going to need to see a mean and a standard deviation to do that. So Poisson problems, while they may have a mean, there's no standard deviation given in those problems. Binomial, you won't see either of those, right? You're given n and that percentage. So normally distributed, we're looking for a mean and a standard deviation. And if we just take a quick look at 2, I see normal distribution, I see mean, I see standard deviation. And if I look at 3, the same thing happens. Normally distributed, mean, standard deviation. So that's what lets us know that we're in chapter 7. Now, what's really important is that we're going to be asked to find a probability. Normal probability problems will ask you to find a probability. When we get to the next page, the reverse normals, it's not going to say to find a probability that a girl is over 92 centimeters tall. It's going to say what percentage, what height separates the top 5% or the bottom 8% from the rest. So those reverse ones are going to be looking for a value like a height, like a time on the exam, like the length of time for the gestation period. It's not going to ask for a probability. It's really going to give you a probability and ask you for the value that goes with it. Now, the idea with these problems is that they use the normal distribution, which can be represented by a bell curve. And StatCrunch is going to draw that for us. But the idea is that the peak of the curve, that's where the mean resides. And here in problem 1, we're told that the mean is 85. The standard deviation is roughly this measure. It's a measure of how spread out, how wide that curve is going to be. And then the question says, find the probability the girl is over 92. So 92 would be somewhere to the right of 85. And we're looking for the probability that she's taller. This area is the probability. So a long time ago, this was a really hard problem because you had to use calculus to figure out what that area is. But that's not a shape that we know, right? We know the formula for the area of a circle or a rectangle or a triangle, but we don't know one for that shape. And calculus would show us that, but now the technology will tell us the area even though we don't know calculus. So that's what's happened here. When you're doing one of these problems in StatCrunch, it's going to ask you for the mean, the standard deviation, and next to X, you're going to have to choose the sign and list the number, and then the answer is going to be given to the right side of that. So there's really 4 pieces that we're filling out here. Again, as I read through the problem, the heights of 2-year-old girls are approximately normally distributed with a mean of 85 centimeters. So the mean is 85 and a standard deviation of 4 centimeters. Now, when we type these into StatCrunch, we don't need the units, but we do need to make sure that they're the same. You know, if the mean was in centimeters, but the standard deviation was in millimeters, we've got to make those 2 match before we try to do this problem. Find the probability the girl is over 92 centimeters tall. That's greater than 92. And the equal sign in chapter 7, whether it's there or not, it's the exact same thing. So the probability that it's exactly equal to 92.00000 is 0. So the equal part doesn't add any probability to it. So what we're really looking for is the direction. All right, I'm going to start up StatCrunch here in a moment, but I do want to write down the directions for getting to the calculator. This one is under Stat, Calculators, Normal. I'm going to split the screen so I can have both parts going at the same time. I've already logged into StatCrunch, and I'm going to open StatCrunch. And again, I'm going to split the screen up. Let's try this. And Stat, Calculators, Normal. Last week in chapter 6, you would have used either custom in 6.1, binomial in 6.2, or Poisson in 6.3. In chapter 7, we only use the normal one. And notice there are places for the mean, standard deviation, the sign for X, and the number. Also, there is a between tab that if you're looking between two numbers, you can use. So our mean is 85. The standard deviation is 4. And we're looking for greater than 92. But notice again, greater than is not a number, a sign that's listed. I use the greater than with the equal sign in that case. And then the number next to X, that was 92. That's what we want to find the probability for that height. And then we compute, and just like in chapter 6, we're going to round these to 4 decimal places. So I look and I see 0.04005. That 5 is big enough to round it up a bit. So 0.0401 is that probability. And these probabilities mean a couple of different things. It's the probability that any one girl is over that height. That's about 4%. Or it also tells us that 4% of all girls are over that height. And again, if you think of it as a percent, 0.0401, that's about 4%. All right, what I'd like you to do is I want you to read through problem 2. And I want you to list the mean, the standard deviation, the sign that you're going to use for X, and the number that you're going to type in. Sorry, I'm writing all this in. You can't see it. There we go. So again, I want the mean, the standard deviation, and the sign, and the number that you're going to use for X. Then after you've got that, I want you to enter this information into StatCrunch and come up with the probability, and then we'll go over it. For those of you watching the recording after the fact, I want you to pause the video and I want you to do the same thing. It doesn't really matter if you get this right or not this time. The process of trying to do it will help you to remember it, even if you make a mistake on this first attempt. Yeah, so in the StatCrunch assignment, right, you need to, just like last week, you can have 2 files if you want to, but you need to show the StatCrunch output. If you only show the StatCrunch output, that's okay. But I would say that when you take the midterm exam, you're way better off to write all this down and share the StatCrunch, because if you make a typo in StatCrunch and I can't see what you wrote down, then I have to guess that you didn't know the right numbers or signs to put in. So if you list it and show the StatCrunch, it kind of protects you. And if you make a mistake, you'll get the most partial credit for that problem. I grade the midterm differently than I grade those activities. On an activity, a problem's either right or wrong. On the midterm, I grade on partial credit. So I have to determine how much understanding you have. And the more evidence you give me, the better your chances are. So that's a really long answer to, I would do both. I would write down everything and share the StatCrunch. All right, let me see if I can catch up with you here. The mean I highlighted, it was 106 minutes. Yeah, you bet. And, oops, sorry about that. The standard deviation I highlighted, that was 12 minutes. And we were looking for the probability that a student takes less than 90 minutes. So less than 90. Type in the mean, standard deviation, change the sign and the value. And you should have 0.0912, which is about 9%. So this is saying that the chance of any one student finishing in less than 90 minutes is about 9%. It also means that about 9% of all students will finish in less than 90 minutes. Any questions on either of those first two before we go on? Now, notice I haven't drawn the curve. If I'm including my StatCrunch output, I don't need to do that, right? I've got all that here. By the way, to copy this and paste this into a document, remember it's under Options, Copy. It gives you a version that's better for copying. You right-click and copy image, and then you can open up your document and paste it in and change the size if you need to. Just be sure that when you look at the document before you turn it in, that I can see the bottom part too. Some students made the picture so big that the numbers didn't fit on the screen. And if I can't see the numbers, that kind of defeats the purpose too. All right, any questions on either of these first two before we try the last normal problem, problem 3? And again, anytime you can unmute yourself or type them into the chat. Problem 3, I already marked up. It says it's normally distributed. The mean is 61.4 days. The standard deviation is 1.7 days. And now for X, it says it lasts between 56 and 63 days. So what we're looking for is X to be between 63 and 56 days. And StatCrunch has a between tab for doing that. So I click between and notice now it has X trapped between two numbers. Put in your mean, 61.4 this time, 1.7 for the standard deviation, and we want it between 56 and 63. When we press compute, notice the graph. Well, 56 is so far to the left. Normally it would show a left cutoff point as well, and it would shade in between those two numbers. But 56 is so far over to the left that it doesn't even show up on the graph. Anyway, 0.82594, that's too small to round up. 0.8259. So here, that's about 82 or 83%. That means if you have a German Shepherd that's going to have puppies, there's about an 83% chance that it'll be between 8 and 9 weeks, 56 days and 63 days. It also means that 83% of all German Shepherds have their puppies within that 7-day window. So the key here is look for normally distributed, and really important, look for a mean and a standard deviation. Now, in these 3 problems that we did, me pull this up a little bit. In these three problems that we just did, they all had the same phrasing. Let me change the highlighter. Find the probability. Find the probability. Find the probability, right? In each case, it's asking you to find a probability of a certain event happening. But when we get to problem 4, this looks like a normal probability problem. So I go through and I see normally distributed. I have a mean of 240 points. I have a standard deviation of 25 points. But it doesn't say, find the probability that this happens. It's asking for a score. What score is required to put a student in the bottom 20% of all scores? So this is what I call a reverse normal, because on the first page in those normal probability problems, we were given a height of a girl, 92 centimeters tall. We were given a time for an exam, less than 90 minutes. We were given a length for a pregnancy between 56 and 63 days. We were given those units and we were looking for the probability. But here, I'm not given the score. I'm trying to find the score. And the 20%, the bottom 20%, that's actually the probability. So what's going on here is if I draw the bell curve, the mean is 240. The standard deviation measures how spread out it is from left to right. It's saying what score puts a student in the bottom 20%. The bottom 20% will be the lowest 20% of scores. So if we think of this number line as representing all the scores, the lowest scores will be the ones with the lower numbers on the left-hand side. So this area is 20% or 0.2 thousand. And what we're trying to find is the value that separates that grouping from the rest. These reverse normal problems will always talk about separating one group, one percentage group from another group. Here, it's the lowest 20%. In a moment, we're going to try to find the cholesterol level that separates the 5% of women with the highest cholesterol from the rest. Now, when we work this problem out, we use the same calculator. I enter the mean. I didn't write it down separately, so let me write that down. The mean is 240, and the standard deviation is 25. I need to come up with a sign, and I need to come up with the number on the other side. I'm going to leave this piece blank. That's where my answer is going to show up. So I'm going to go back to the standard calculator, and instead of the between tab, I put in the mean, 240. I put in the standard deviation, 25. I'm looking for the lower value, so I'm going to use the less than sign. If it said the top 20% of all scores, then I would use the greater than or equal to sign. And then I put the 0.20 for 20% here, and then compute. And my answer is going to show up right here, 218.95947. It doesn't tell us where to round here. So it does at the very top. It's to round to one decimal place. So 218.95, that's going to round, that 5 is going to round the 9 up. And then we're going to carry a 1 over. So this is actually going to be 219.0. That is the answer. That's the time that, the score that separates the lower 20% from the rest. Where do students get in trouble here? The biggest issue actually is right here, making sure that you have the right sign for X. And I think that drawing the curve will actually help you to do that. Again, you've got to think of the number line, what that represents, and whether you're looking for numbers to the left on the number line or numbers on the right. So what I'd like you to do, and we're going to take a quick time out to do this, I want you to set up and try problem 5. It says the LDL cholesterol level for adult women tested after an 8-hour fast follows a normal distribution with a mean of 113.6 and a standard deviation of 34.7. What is the LDL level that separates the 5% of women with the highest cholesterol levels? So notice it's not asking for a probability, it's asking for a cholesterol level. So we're trying to work this backwards. You're going to need this sign and this number. And again, your answer will appear here. Round it to 1 decimal place. In a moment, a minute or two, I'm going to ask you for your answers. For those of you doing this, watching the recording, pause the video and try this and see whether you get this correct or not. And again, just round your answer to 1 decimal place here. When you have it, do me a favor, go ahead and type your answer into the chat. There's a couple of places where this one could go wrong. And like I said earlier, it's okay to actually get this incorrect. What I'm actually hoping for is that you make some mistakes along the way here so that you'll remember that going forward. The mistakes are actually pretty valuable here. Yeah, Robert, actually, I don't know the right answer, but that seems like that's in the ballpark. We were looking for the value that separated the women, the 5% who had the highest levels. So if cholesterol is this number line on the bottom here, the numbers are getting smaller to the left and higher to the right. That means that we're looking for this value that separates the top 5% from the rest. So that means we need to use a greater than sign. That's the first place where things can go wrong. The second place is changing 5% into a decimal, because I can't type 5% here. I have to type that as a decimal. 5% is 0.05. And a lot of times with these single digit percentages, students will just write 0.5 instead, but 0.5 is really 50%. Just remember, like we did in those worksheets, you want to move the decimal point 2 places to the left, and that brings the 0 in front of it. If you want to play it safe, you can go to Desmos and divide by 100. 5 divided by 100, 0.05. So back in StatCrunch, the mean 113.6, standard deviation 34.7. This time I want greater than or equal to and 0.05. 170.7. If we round to 1 decimal place. Now, with these problems, let's let me get rid of this and let me suppose I picked the wrong sign by mistake. So say I did less than or equal to, and I type in the 0.05 and I get my answer. And then I realize, oh, no, that's not right. I needed to use greater than or equal to. Watch what happens when I change this sign to greater than or equal to. Keep an eye on this number and the number after the equal sign. When I switch it from less than to greater than, notice that it changes out that 0.05 on me. So even though I changed the sign, I don't have the right answer now. I have to retype that area to get the correct answer. So be careful of that. If you change anything, you're basically better off to start it over from scratch. All right, any questions on either of these two before we go on to the last type of problem?
So, sorry. So for the reverse normal, instead of putting it like where the px is, you put it at, you put it like behind the equal sign.
Perfect, yeah. So that's right on the money. So in the reverse normal, you're always going to fill in the right-hand side where our answer used to go. And the number that we used to type in, that's going to be your answer for that one. So everything is really backwards from the type that we did on the first page.
All right, that makes more sense.
Good, good. And you'll definitely see these on the midterm, right? Chapter 6 and 7, they're all going to be jumbled together. So there's going to be some binomial, some Poisson, some normal, and some reverse normal. And I think that probably the best start is to read through and try to identify them. And I will tell you how many there are of each type. And then you should go through and try to identify which ones are which type before you try to do them all. The thought process for me is, while I'm in the identifying mode, let me go through and identify all of them. Then I can come back. Doing them is not the hard part. I think identifying them is the hard part. Setting them up. Any other questions on this page? So I don't have these for you in a StatCrunch worksheet, but we do have to use, I'm going to have to refer to the notes from section 7.3 because I need a table to get the critical values here. So I'm going to open up those notes real quick so I have that available. But we're going, when we get back into StatCrunch, I'm going to have to type these numbers in to one column for problem 6 and one column for problem 7. Let me get this into its own window. Just a sec. This table has the critical values. This is really the only table that we have to use in this whole book. You're going to want to keep that with you, but on the midterm, I'm pretty sure that I will give you either a copy of the table or the value you need to use. I haven't typed the midterm yet. So normality, what we're trying to figure out is whether a set of data could come from a normal distribution. And so it's hard to tell with a small amount of data, like 11 values in problem 6 or even 20 values in problem 7. It's kind of hard to tell, but StatCrunch creates a graph that will help us make that determination. So problem 6 says, here are the ages of 11 randomly selected COS students. Are the ages normally distributed? So that's how I know that it's a normality problem. Is this set of data normally distributed? I'm going to type problem 6 underneath where it says var1, 17, 18, 19. There's a couple of 20s, a couple of 21s, 22, 24, 29, and 33. So there's the 11 values. Now, when you take your midterm, and I'll say this while I'm letting you type, you don't want to get a problem wrong because you've typed values in incorrectly. So there's a couple of things that you can do. First, you can go back and reread them. 17, 17, 18, 18, and go one at a time. Just make sure they match up. Check them both directions. But what you can also do is you can have somebody that you know be your eyes. So you can read what you typed into StatCrunch while they're holding the sheet in their hand. And so you can read the number 17, 18, 19, and they can make sure that you're saying the right numbers. Sometimes getting a second pair of eyes on the data is really helpful because you don't want to get a problem wrong because you typed a 21 as a 12. Or you skipped one of the 21s or something like that. So I do think that getting somebody to help you with that part is a good idea, and I would really recommend it. First thing that we do is we're going to make a graph that's called a QQ plot. So this is under graph QQ plot. Graph QQ plot. Pick the column that has your data. This time it's under that first column, var1. Couple of things that you need to do. Where it says add, check the box for correlation statistic. And also the box that says normal quantiles on y-axis, check that too. The top one you need to do all the time because this correlation statistic that StatCrunch is going to give to us, this is what we're going to use to figure out whether it's normally distributed or not. The second box is really only important when you're doing MyLab work. MyLab is going to give you a choice of 4 graphs to match up to, and they make all of theirs by putting the normal quantiles on the y-axis. So if you don't check this box, your graph is going to be kind of a mirror image of what it needs to be. And so even though we're not using it, I think it's a good idea to get into the practice of checking that. Click compute. And what we're hoping to see is the points lining up pretty straight. Now this one, I can see that they kind of bubble up to the top here and they're a little low on this side below that line. You can't really tell by looking at the graph, but the idea is it can be kind of far away at the two ends, but it should get close in the middle. So it's almost like if you draw 2 semicircles above and below, all the points should be between those two. But knowing exactly where to draw the semicircle is the hard part. So we're going to make our decision based on the calculation it gave us, 0.916. So we're going to write that down. That comes from the graph. Then I need the critical value. I had a sample of size 11. And so I'm going to use my table to find the critical value. What the critical value is saying is if you get a correlation above this number, they're normally distributed. And if you can't beat this number, they're not. So I've got the table. Oops. For n equals 11, the number to beat was 0.923. If the correlation, and again, that's from the graph, is below the critical value, which is from the table, that means that the data are not normally distributed. They do not follow the bell curve. So the correlation statistic had to be above 0.923 to be convincing evidence that the data follow a bell curve. Now, if I were to make a histogram of this data, and don't make this, I just want to show you, we can start to see why maybe this wouldn't be normally distributed. The left side looks like it could be, but the right side is definitely not following that kind of symmetric pattern. And so, but the histogram's not enough to tell alone either. So the only way we can do this is by making the QQ plot and comparing the statistic on the graph to the value from the table. So we've got one problem left to do, and we're gonna, I want you to do the same thing. What I want you to do is I want you to get these 20 numbers into StatCrunch and find the correlation statistic. Then when we're done with that, we'll go to the table to get the critical value and make our decision. I'm going to read the numbers out as I type them under var2. I'm going to go across the top row first: 97, 81, 73, 102, 93, 95, 84, 90, 74, 114. So there's the first 10. And then the second group of 10, 102, 74, 73, 94, 107, 99, 97, 84, 105, and 97. So get all of those into one column. Even though I typed them side to side and it looks like there's two groups of them, that's considered one set of data. So all into the same column, and then you want to use graph QQ plot to generate that statistic. Now, typically it gives you 3 decimal places, but every once in a while it'll only give you 2. So you just write down whatever it does give you. Yeah, so for the chapter 7 activity, there's a couple of problems that ask you for normality. The graph you're going to make is the QQ plot, and then you're going to use this table to get the critical value from it. All right, I'm going to pick the column that has the data in it, var2, and I'm going to check the 2 boxes and click compute. And this time I've got 0.969. Now, if you look at the graph, it still kind of follows a wavy pattern over here. So that's why the graph alone is not enough, because it could be scaled differently depending on the graph. But that number is the number we're using, 0.969. If we look at the table for n equals 20, the number to beat is 0.951. So let's see. Let me zoom in a little bit. When n is 20, when the sample size is 20, the critical value, the number to beat, is 0.951. And this time, the value from the graph is bigger than the value from the table. That means that they are normally distributed. So if you were to look at let me just pop this open. If we were to look at the chapter 7 activity, and you're going to notice that it's kind of similar to what we've done here. There we go. Let me pop that open. These are pretty similar. The data have been changed. There are more values, less values, but it's the same idea. You're going to get the number from the graph. You're going to go to that table that I just showed you and get the critical value. And then if the number from the graph is above the number from the table, they are normally distributed. If the number from the graph is lower than the number from the table, they're not. In this case, we got one of each. By the way, if we take a look at the histogram of the second one, it's tough to tell from here either, but what StatCrunch is calculating is that this right side looks roughly bell-shaped, that even this little variation here isn't enough to throw it off. Any questions on these last two? Just a couple of things I wanted to point out, thinking about chapter 7. Things are a little different this week. So we still have the regular chapter 7 activity, but you have a flow chart, which is a different assignment than we've seen so far. Last week, I gave you a flow chart for figuring out how to tell if a problem is binomial or Poisson. You're going to take that idea and also add in the first two types of problems that we did tonight: how to spot a normal probability problem and how to spot a reverse normal problem. So now you'll have a four branches on your flow chart: one for binomial, one for Poisson, one for normal, one for reverse normal. The discussion board, it focuses on normal versus reverse normal. And you can use both of those assignments to help you with the chapter 6 and 7 reading assignment that's due in the support course this week, where you're identifying a problem as binomial, Poisson, normal, or reverse normal. Finally, the last piece here, this goal setting 2, this is only for students who did goal setting 1. So it's only going to be extra credit. It won't count against you if you miss this one too. There's one more that's on the way. And so you'll have one more shot at that. But I think it's going to happen after the midterm. Let me switch over to your support class for a moment. So this week, the square roots assignment and the exponents assignment, this is the end of the math in Math 321. After that, all that remains are some of the time management discussion boards and the reading assignments. Now, notice that the second one is up and posted. There are 3 more to go. We'll do one after chapter 10, one after chapter 11, and one right before the final. So there's 3 more to go after that, but that's basically the math part of that class is gone. The only thing that's going to remain are the study skills, discussion boards, and those reading assignments. All right, let me stop the recording and, whoops.